Hello. Today we're going to talk about solving literal equations. So you might ask, what is a literal equation? That's an equation that is not going to, first of all, give you an answer such as x equals 3. You're solving the equation in terms of another variable. You'll notice in these equations you have two or more variables, and as you solve it, you just want to isolate the one that's indicated. So let's take a look so we understand better. We have the equation here, 7x minus y equals 14. We want to solve for x. What does that mean? That's right, we want to get x by itself on one side, okay? So let's look at this. We solve this as we do other equations. As a matter of fact, let me put another one up here that's very similar so we'll know what we're doing, okay? What if I also solve at the same time 7x minus 3 equals, let's just keep it at 14. Now you notice there we have just one x, so we can solve and get a number. So when you look at that equation, what's the first thing you would do? Correct, you deal with the addition and subtraction. So I want to move the 3 to the other side to be with the other number. So because it's negative, or behind the negative sign, the minus sign, we will add it to both sides. So then we do that, so this will cancel. Negative 3 and positive 3 will cancel. So let's think about this. We want to start getting the x by itself. So let's move what's either being added or subtracted from it. So what are we going to do? We're going to add y, because y is being subtracted. We want to move it to the other side. So if we do it here, we do it here. So this cancels. So over here we see that cancels. We have 7x equals, and this is 14 plus 3, so that's 17. Okay? So let's work on that step over here. So the 7x comes down. We see the y's cancel. Now we notice 14 and y are not like terms, therefore we cannot add them together. So we just bring them down as they are. Equals 14 plus y. If that had been a minus y, we would have said minus y. Okay? So we're still doing good. We're doing good. So what would we do? What would be our next step on this side? Correct? We would divide by 7 because we want to undo the multiplication. You undo multiplication by division. So what we do on the right, we do on the left. This would cancel, and x would leave us with this fraction, and we would leave it in fraction form and not go to decimal. So there we have an actual value for x. But over here, because we have more than one variable, we're going to have an expression. So on here, same way, we want x by itself. We want to undo the multiplication, so we divide by 7. We have to divide everything by 7. So the 7's cancel. That leaves me with x equals all of this, because I cannot, well, actually, I'm going to be able to simplify. But right now, we're going to bring it down like it is. So 14 plus y over 7. Now, this is pretty interesting. In this case, the 14 and the 7 can simplify. What can divide into both 14 and 7? Right, 7 can. So I mark those out, and I say to myself, 14 divided by 7 is what? That's a 2. 7 divided by 7 is what? That's 1. So I end up with x equals 2 plus, I'm leaving something out, 2 plus y, that's right, so sorry. 2 plus y. And if it's over 1, we know that doesn't change the value. So in this case, we did have a reduction that could be done, okay? So let's look at example 2. We're going to solve a equals x plus y divided by 2. We're going to solve for y. That means we want to get y by itself. So when we look at this, right now, this is a sum. I can't just separate it, but I can work on getting it from over the fraction. So I'm dividing by 2. So what's the opposite of dividing by 2? Correct, multiplying by 2. So I'm going to multiply both sides by 2 over 1. Why did I make it a fraction? So I can see this is going to cross reduce. And what I do on the right, I must do on the left. So my 2's cancel here. Going left to right, 2 times a is 2a. And then comes down to x plus y. Okay? 2a equals x plus y. Now I still need to get y by itself, so what am I going to move? I'm going to move the x. The x is positive, so we're going to subtract it from both sides. Positive x and negative x cancel. Over here I have 2a and a minus x, a negative x. So they don't combine, they're not like terms. So we write them down as they are. I'll start with 2a minus x equals, and we have left over here a y. So your goal was to get y by itself, and it is. Y equals this, and y is isolated. It doesn't matter if it's isolated on the left or the right. If you want to rewrite it, you can, and you can say this. That's the same thing. Okay, let's move on. Here in example 3, we have a formula. This is the formula for volume of a sphere, like a basketball. We're going to solve for h. This is really easy. There is basically one step. What's happening on the right side of this equation? All of these are being multiplied. That's pi times r squared times h. It's all being multiplied. So to undo multiplication, what do? We divide. So I want h by itself. That means I need to get rid of the pi and the r squared. So I'm going to divide by pi r squared. If I do it on the right, I must do it on the left. Okay? Well, these cancel, leaving me what? The h. That's what I wanted by itself. And everything here just comes down. V equals pi r squared. And we're finished. I told you that would be an easy one. We got h by itself in one step. Let's look at another example. Now we have 3t plus 4z equal 5, and we want to solve for t. So that means I want the t by itself, okay? So we look at this. Well, right now, this is being multiplied, so it's together. So we want to do our addition and subtraction first. We want to move what's being either added or subtracted first in this case. So we want to move the 4z to the other side. It's being added, so what do? We subtract. And what we do on the left, we do on the right. You'll hear Ms. Norman say that quite a bit. Okay? Now we see that these cancel, and what comes down? 3t equals, now 5, again, and 4z are not like terms, so they do not go together. So we bring them both down as they are. Now, again, we want t by itself. So what's happening over here? They're side by side. They're like shoulder to shoulder, so that tells me they're being multiplied. So to undo multiplication, what do? That's right, division. So I'm going to divide by 3 on both sides. That cancels, and t comes down, and look, lo and behold, it is by itself. It's alone, it's isolated. And everything on the right side comes down as it is. Now this one is already finished. Why? 5 and 4 and 3 do not have a common divider. In other words, there's not a number, that will go into all 3 of those numbers to reduce that, except for 1, and we know 1 does not make a difference when we divide by it. So here is your answer in its simplified form. Okay? We have 2 more examples we're going to do. This one is 3y plus 15x equal 12, and we're going to solve for y. An equation like this is quite important because when we start doing slope-intercept form, y equals mx plus b, you will need to get equations that look like this into slope-intercept form. So this is great practice. So what do we do when we want to do this? If you want to get y by itself, the first step is to move the x term to the other side of the equation. So we're going to add 15x, add 15x. cancel happens here. What comes down? 3y equals. Now, if you get in the habit of remembering y equals mx plus b, that format of the formula, you will know you'll write your x term first plus 12. Now you say, well, Miss Norman, does it really matter? No, it does not. But when we start doing slope-intercept formula, you have to find the slope and the y-intercept. This will help you recognize it because the slope will be with the x and that'll be the y-intercept, and it's all in the right order, okay? So just practice it now. If you're solving for y in an equation and you have x also, write down the x, then the number, okay? Now, our second thing, our last step we're gonna do is divide by the 3, so x can be by itself. So we divide by 3, and we divide by 3. Now, this is gonna be really cool because a lot of things are gonna reduce over here. We know this is gone, so we have y equals. Well, let's take a look at what we have left over here. 15 and 3 and 12 are all divisible by 3. So let's do that. 15 divided by 3 is 5. 12 divided by 3 is 4. 3 divided by 3 is 1. So we bring down what is remains. 5x plus 4. Again, being over 1 does not change the value of it because when you divide by 1, there is no change in what you had prior to. So now we have y by itself, and it's also in slope-intercept form, which we'll be doing in a few weeks. Our last example. Okay, we have P equals A plus B plus C, and we want to solve for B. Now on this one, what you want to kind of think about is if we find the perimeter of something, okay? So that's where you might see an equation like this. We want to solve for B, that means I want B by itself. So let's take a look at this. A is being added to B, and so is C. So to undo addition, what do? You're right, we subtract. And it doesn't matter which one you do first, take your time. So first I'm just gonna choose the A first because it is first. So I go minus A, the A's cancel. Because P is positive, I just put it first. It really doesn't matter. I can say negative A plus P, but I'll just start off with the positive P minus A equals B plus C, okay? Now, I still want B by itself, and I'm adding C over there, so I have to subtract C. So I go minus C. That cancels. Now over here, now I have P minus A minus C equals B. B is isolated. That's what we wanted to do. We want to solve for B. So this is your final answer. P minus A minus C equal B. And again, if you want to rewrite and have your letter that's by itself on the left, you can say B equals P minus A minus C. And that's our lesson for today over literal equations. Good luck.